Assalamu alaikum. Can you hear me?
Waalaikumsalam, Ken Madam.
Okay, let's just start. So for the genetic algorithm, this two is the given exercise. Like one is using some binary codes, and another one is traveling salesman problem. So if we just go through the lecture slide, uh, genetic algorithm is kind of using natural way of reproduction and other things. We are using that sequence to improve our optimization or search algorithms. So basically it consists of like crossover and mutation, and there's a so these are the steps where we just choose a population n and the crossover probability pc and the mutation probability pm. Then we do some fitness calculation, and we just like do the crossover and mutation, and keep repeat the process until like some condition meet. So so it can be like bit string, real number, permutation, a list of rules. In this case, there are like bit string given in the given exercise. So sometimes we have to select the parents. Parents are selected at random with selection chances biased in relation to chromosome evaluation. And evaluator decodes a chromosomes and assign it a fitness measure. So fitness function it will be given, and so these are the basic of like genetic algorithms. So if we go back to the given problem here, the first question it says, let us find the maximum value of function this f of x 15x minus x square, where parameter x varies between 1 to 15. For simplicity, we may assume that x only takes integer value. Thus, table below shows the possible chromosomes that build with only 4 genes. So these are the integer values from 1 to 15, and these are their binary representations. Like 1 binary code 001, for 2 0010. Like these are the binary representation. This is 6 0110. So and 11 1011. So uh, the uh, value of x is like between 1 to 15, okay, and this is the function, and we have to like find the maximum value of this function. And let's just start. Okay, so to do that, first we need to create a table with this, like we let's just take six chromosomes from here, any six number you want, it's up to you. After that, we are labeling them as x1 to x6, and we are taking six numbers. We have written their binary value and integer value. So after that, we calculate the chromosome fitness and fitness ratio. So how can we calculate this chromosome fitness? To do this, we will use the given function f of x. So f of x is the given function. Here we have taken 12, 4, 1, 14, 7, 9. This 6 integer values. So for 12, like f of 12, it will be 15 into 12 minus 12 square, which is 36. Similarly, for f of 4, it is 44. For f of 1, it's 14. F of 14, 14. F of 7, 56. F of 9 will be 54. So these are the chromosome fitness values. For the fitness ratios, we just need to add them all. It will be 218. Just add the fitness values. Then the ratio will be the fitness value divided by total value into 100. So it's 16.5 for x1. For x2, it's 20.2. For x3 is 6.4. For x4 is 6.4. x5 25.6. x6 is 24.7. So among these, the highest value is 25.6, which is x5. So x5 integer value is 7. So we can say that initially for 7, this function gives the maximum value. After crossover mutation, we will find out what are the others number which give the maximum value. So after finding the fitness ratio, we just uh, label them as what which one is the maximum one. Like 25 points is the maximum, so it's first. Then second is this one, third is 20.2, and fourth is 16.5. So yeah, we have taken largest four ratios, and we have created these tables. And if we draw the a diagram using these values, like this is like for 7, the value is between 50 to 60. So this is 56. So initially we can say that for value 7, we get the highest chromosome fitness. Okay, this is taken from like sheet here. Mm, it is from, yeah, this one. Okay, so now we have calculated the fitness ratio. Now we will do the crossover. Okay, for crossover, let's just take x6 and x2, like x6 the second one and x2 the third one. So we will do crossover in like in the middle, like at position 2. So what crossover at position 2 will do, like this is the head of the x6, this is the head of x2. So at x6, the tail of x2 will be added. Okay, 10 is 6x6, and 00 is from x2. Similarly for x2, the head of x2 will be same, then the tail of x6 will be added to x2. This is how crossover will be done. Okay, then crossover of x1 and x5, the other two, x1 and x5. So for x1, x5, let's do crossover at position third position. From right to left, we count like this is third position. So this is the head. The others is from like x5. Similarly, this is x5, and this part is from x1. So we have done the crossover, and after that we choose x1 prime and x2 to do the mutation. Mutation is we just choose uh, one bit of gene um, and change it randomly. Okay, for x1 we got after changing we got 111. So during mutation we just change this third one to 0. This is mutation. We can do it for like 1 or more bits. Like for x2, we for x2 like we change x1 prime to 1011, and for x2 we just directly change the x2, not x2 prime. Okay, so x2 was given here 01, yeah, 0100 x2. So we just change last two bit of this um string to as this, like 0110. We change this one. Okay, so after doing this crossover and mutation, we can create a table like this, like at chromosome I generation. It's in the sheet here. Okay, it's here, x6 and x2 crossover, x1 and x5 crossover. We just take x2 and x5 as it is, then just x1 to mutation and x2 to mutation. Okay, after that crossover and mutation, we get this generation I plus 1. This one is the initial values, generation I. After the process, we get generation I plus 1. So for the generation I plus 1, like here, the thing is, we will add this new, these are offspring, like these are the parents, and from parents we get offspring. So these offspring will be written sequentially, like the first one will be 1000, the second one will be 0101. So that's what written here, 1000 0101. Okay, sequentially. And as for parent, we write for parent was x6 and x2. um, for x6 was initially 1001. We do crossover and we get 1000, no mutation. For x2 it was 0111. We after crossover we get 0101. We didn't do any mutation, so it is same. And from the x1 and x5 here, crossover of x1 and x5, we get 1111 and 0100. Yeah, 1111, but we did mutation once. Okay, which that's why it became 1011. And for the next one, no mutation, so straight 0100. And then we choose like x2 and x5. Okay, x2 and 5, as it's in the sheet, x2 and x5. And x2 and x5, from this, uh, we know, right? X5, for x5 we got the highest values, so we do not want to lose this highest value of bit string. Okay, so that's why when doing crossover of x2 and x5, we keep we do not let any other gene overcome the, override this highest value. So for 0101, we just do the mutation and change a bit, but we did not do any changes in this like x2 and x over crossover. We keep like 0111. 0111 was this one, where it is, 001, as same as x5, like x for between x2 and x5 crossover, x5 remain unchanged. Okay, it didn't let x2 to overwrite it. That's just it for the last two values. So we did mutation for only two values, and this is at the final chromosome. Using this, we calculate the fitness function again. Like for 1000, this is 1000 means it's 12, right? So 12, so x 1 plus 1 actually 12. Okay, integer value 12. So for f of x, it is kind of f of 12 is equals to 15 into 12 minus 12 square. The same, maybe it's a bit 12, 36. It will be 36. Maybe there is an error here. 15 into 12, yeah, 36. So using the same function f of x here, f of x, we calculate the uh, all the fitness chromosome again, and after doing this, we will get that for 1000, and for 0111 we get highest fitness values. That's the answer, which is also given here, like 7 and 8 are the optimum number for f of x is equals to 15 minus x square. Okay, so this is the first one. And after that, there's another question for like traveling salesman. The traveling salesman problem is, we have to visit every city and calculate the minimum, like shortest distance to visit uh, each city. Shortest visit, and after visiting all of these cities. Okay, so the problem says, traveling salesman problem is a classic problem which you have to solve the shortest route in order the salesman visit each city. Below are the maps of the city which the salesman has to visit. So create 6 chromosomes to represent the route, and which salesman has to travel and evaluate the fitness for each chromosome. We just create 6 paths that will be considered as 6 chromosomes. Then we will just calculate the fitness values. It's simple. Okay, so it's just random. Randomly we can create 6 paths from, like, let's just start from A. So A, B, D, E, C. A, B, D, C, E. Then F, G, G, I. It's up to you. It's totally up to you. You can choose a path randomly. Just the condition is, visit every city. Okay, you don't need to consider the arrows here, like only from A to B, A to C you can go. There's not it can take it as an undirected graph. Okay, just you can visit every node, from every node. Just write 6 random paths. Okay, just touch all the letters. By this we will get 6 chromosomes. Okay, so 6 chromosome. Now we how do we calculate the fitness value? For f of c1, we just calculate the distance needed from one to another node. We just sum all of those values. For example, the first one is f of c1, this one. So first A to B. So from A to B, the cost is 30. So 30 is added here. From B to D, the cost is 20. 20 is added here. Then we are now at D. So D to E. So D to E, there is no direct path. So we can choose this one or this one. It's up to you. It's up to you. There is no correct answer or fixed way. It's up to you, as you choose, like from D to E. Let's just choose this path, and for this path we only consider the new cost, okay, because while coming from B to D we have already considered this path, okay. 20 cost is already added here. So when going to E, we will just add 27, okay. 27 is added. So from D to E we now add E, then we go to C. So from E we go to C. So we can take this path, we can take this path, we can take this path. So let's just choose this one, okay. So from E to C, 18 plus 19, 18 plus 19. After that, C to F. C, for C to F we have already visited, so we do not need to add again. We are just now at F. So from F we go to G. G is here, so we can choose this path or this one. So let's just choose this one, like already visited this path, 18. So let's just take 22 and 17, so we can reach G. So at G we go to I is here, so let's just choose this path, 43, 18, 18. Okay, 43, 18, 18, it's added. Now we are at I. From I we need to go to J. J is here. As we have visited this path, 18, 18, we just need to add 16 here. So 16 is added. Now we are at J. From J go to K. K is here, and these paths are already visited, so we do not need to write it again. We just reach K. So after K we go to L. L is here. Again these paths are visited. Then from L we go to H, and these paths are already visited, so we do not need to write the cost again. So just we reach H. So after that, if we do the summation, we will get 248. Similarly, for C2 to C6, we get values like this: 229, 302, 245, 220, 257. Okay. So in the previous question, the task was to find the maximum fitness value, and here the task is to find the path with minimum value, okay, because we want to find the shortest path uh, of visiting each city. So here if we rank them, this is the shortest path, like 222 is the minimum value here, so this is the first one, then this is the second one, and the third one is this one, and this is fourth, and this is fifth. Now after that you can calculate like the ratio, also fitness ratio. For that you just need to add all of this, and divide for this one, 248 divided by total value into 100, as we have done previously. We can do that fitness ratio. Let's just do the crossover and mutation. For example, you can choose it randomly, but it's better to choose with like highest fitness values. But let's just generally do some crossover techniques, like for example, if we do crossover of C1 and C2, okay, this is the head of C1, this is the head of C2. For new C1, I'm just showing you the example, like what's the technique to do crossover for this like of alphabet, because it's a bit different than the previous one. Like for example, this is C1, we are doing a crossover here. So for that, first we just take the head part of the C2, okay, we just write it, and after that we will write all the letters from here, like from start to end. We will just skip these four letters, because we have already written it, we have got it from C2. There can not be like two two same characters. Okay, two same characters cannot be written in a same chromosome. So we just first write the head part of C2, then we write A, B, D, E, A, B, D, E, then C, F, G, C, F, G. We have read C, F, G. Then there is I, J, K, L. But L, K, I, J, like I, J, K, L already written. So we skip this part and write H only. Okay. And similarly for C2, we just write the header part of a C1, and we write all the letters from C2 just by skipping these four letters. Here LKIJ, then FCGH, and EDBA are skipped because we have already written it here. Similarly for C3 and C4, this the header part. So C4 is added as header part of C3, and others letters are already written here. Okay, and similar for C4 also. And here this is another kind of mutation. We just exchange the last two position. Okay, exchange two position. For example, the first position is K, the last position is G. In new chromosome we exchange like the first position G and the last position K. Okay, just exchange some uh, by taking two random position and exchange their values. This is another kind of crossover. After that, we will get new path again. Like this is the new path, this is the new path. Okay, we get new chromosome, so we have to do the calculation, fitness calculation again for this new path, similar to this one. Okay, so after calculating all these values, we will get 222 as our shortest path, because in this path we will also not get any minimum value less than 222, which we got in the first here, 222. But there is no minimum value less than 222, so we get 222 as our answer, and the shortest path is FC5, and shortest path is this one. So this is the answer for traveling salesman. So I am sharing this with you. Mm, you can take some time to look at this solution. Let me just give you the attendance sheet. Okay, it's the same sheet like you did on the previous class. Just write on the third sheet. Okay, 15 1 2025. Look below, there are third sheet including date today. uh, Here, just fill in this sheet. Okay, section 2, 15.1. I have added the date. Give your attendance here. Okay. Do you have any question? Okay. This is for today. Like this two exercises from genetic algorithms. I have shared with you the answers, and maybe question is already given in that column. So that's all. Um, if you face any problem or any confusion, you can ask in the group or you can text. That's all. Okay. Thank you. Assalamualaikum.
Waalaikumsalam, thank you, madam.
Okay. Thank you. God bless.